Okay, so we're going to go over the test review. Any questions that you guys have? Oh, I should probably open up my webcam really quickly. What page is the test review on? Okay. But I do want to point out for you guys a few different things that might also help you for the test tomorrow. So I do have, there we go. Uh-oh. Ugh. All right, I do have the test review ready for us to go over questions, which we're going to do. However, also we have the Chapter 4B practice test. But if you guys notice, I went ahead and put the practice test with the keys. So the first few pages are the practice test itself. There we go. I was taking those scanned pictures with my PDF reader on Friday. But then also, haha, look at all these answers and the work. Anyway, so that's something for you guys to realize. Ooh. Oh, sorry, those are the blank versions. There we go. So the key is after that for the practice test with the work shown. Also, if you guys notice, I haven't shown you this yet, but in your notes, I'm going to save today when I save the PDF, that's in our class folder, class notes, I do have some big idea problems that would require completing the square. Some of them actually, hey, with the solution, some of them actually might be in that practice test that you have, but here are some other big idea problems. So maybe if you guys can't do the practice test, there are, like maybe you're like, there's no way I'm going to get it done, or it's too overwhelming. There are 4 big idea problems at the very end of your notes with solutions, so questions and solutions. Does that make sense? Okay. But let's go ahead and see what you guys have as far as questions on the test review itself. I'm going to go ahead and get some blank pages ready so I can copy and paste in so we can see what's going on. Shoop, 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 shoop. All right. What do we have, kiddos? Do I have any more quizzes that are out? Thank you, thank you, thank you. Oh, you just found it? Oh, I don't know whose it is. We know that one's Priscilla's. P.S. Mrs. Regan's message on the front board is not to the exclusion of any of you. If she knew everyone who was in my classes, I'm sure she would have said hi to all of you. She just saw Priscilla's name when she did nursery on Sunday because their nursery for their church is in here. And then she knows it's my room, so she was just saying hi. Okay. What do we got, guys? 83. Anything else besides 83? 65. 61 and 65.
69.
And 85. So I could steal, well, I better steal them separately or else we're not going to have room to solve them, huh? Okay, so we have 83 right up here. It's hard when you think you hear something to then like go back and realize it's something different. Ooh, 85! Looks a lot like a lot of things that we saw last week, whether there was an ln in an integral, whether there was an arcsine in an integral, whether there was an arctangent in an integral. Some of you with colored pens right now need to be ready to make some notes about what to always do when you see, or practically always do when you see. We also need number 69. Is there anything else? 69, 83, 85, 81. Let me go grab 81 while we're there. If any of you guys realized you didn't know those integral rules very well when you took the quiz today, what do you still need to do before tomorrow? Yeah, if you don't have the rules, how sunk are you? Oh, dear. Well, not totally over, because U sub doesn't necessarily always need the new rules, right? But, yeah, it'd be a little dangerous. Why am I saying U sub? What are the big topics of this chapter? U sub, and then we have stuff with logarithmic answers, right? Like the integral of 1 over u, or the integral of tangent of u, or secant of u, or cotangent of u, or cosecant of u, or inverse trig. Isn't that everything? Oh, it sounds so basic, except U sub says, oh, what do you have to be able to do? All the integration from before, just with U's, integration on crack, etc., etc. Let's start here, and then we'll see how much time we have and whether we can take more questions. So, number 69, whenever, some of you, colored pen, make a note. Whenever you see a mess under a square root, you almost always make that mess your U, whether it's in the denominator or whether it's in the numerator. You almost always make the mess your U. So I'm going to make U equal to my 1 plus y. Why am I going fast today, guys? Well, it's chapel schedule, and with review, you've already had time to try it, and you've gotten stuck. We're not like checking answers, etc. You already know what you got or didn't get, so I'm assuming that you tried, and I'm just trying to show as much information as possible. Why do I need to change this to 1 minus y? Because I just said do the guy under the square root. Du would be equal to negative dy, just like it would be for dx. So dy is equal to negative du. So when I go to plug in over here, I'm going to have 2 pi. I'm going to pull out the negative. When I go to plug in my du for dy, I'm going to have square root of u. And what on earth am I supposed to do with this guy? Go get your y. This is called classic integration on crack. Classic integration on crack. I can go ahead and plug in u plus 1 would be u plus 2. Now, guys, is there any rule? Because I have to anti-derive. Is there any rule for multiplication? So what do? I distribute. Now, I am going to have to go ahead and say for x within, I'm just going to keep the x bounds and get back to x's eventually. So I'm going to have negative 2 pi times the integral of u to the 3/2 plus 2u to the 1/2. And hopefully we all are thinking power rule right now, right? I'm going to put my 4 x's within 0 to 1. So I'm going to go ahead and have my negative 2 pi. U to the 5/2 times 2/5. So I'm going to have 2/5 u to the 5/2 plus u to the 3/2 times 2/3. So that'd be 4/3 u to the 3/2. You know what, actually I might be lazy and not do the x bounds. Maybe I'll do u bounds because I don't really have room to go back to x's anyway. Remind me, guys, how do you do u bounds? Yeah, plug in. So we're going to have to plug in u of 1 and plug in u of 0 because those are my old bounds. Plugging in 1, 1 minus 1 is 0. Plugging in 0, 1 minus 0 is 1. So I have 0 on top, 1 on bottom, which is kind of weird, but that's okay. If you guys want to switch them and make that a negative, you can. Technically, since we're just solving for a number, I'm not going to stress about rewriting it. But if we were trying to rewrite it, wouldn't we get common denominators like we saw last chapter, chapter 4a, and pull out that u to the 3/2? And we would simplify. AJ, what's up, kid? No. These are y's, kiddo. We have to get the u's. Did I do it too fast? I might have. Add y, subtract. Yeah, no, it would be. I was talking and not thinking. If anybody else saw that earlier, especially if I'm trying to go fast, do I ever get mad at you for speaking out in class? No, so please speak out way sooner, because that took us the entire problem to figure out. That's a bummer. My du still equals negative dy. That was all fine. So when I go to plug in, I have 1 minus u plus 1, so that'd be 2 minus u. So I have 2u to the 1/2 minus u to the 3/2. To be honest, kiddos, at this point, I don't really think that you guys should have gotten stuck. So maybe we got stuck before this, because at this point, we are just going to go ahead, like I was just saying. We're going to do our power rules, and then we're going to go ahead, and now we have our u bounds of 0 and 1, and we're going to plug and chug. I'm going to do a ... because that pulls you up to power rule. Plug it in. For number 81, there are a few different ways of doing this. I think I would have naturally gone on number 81 with making the entire denominator. With making the entire denominator my u, except when you guys look at it, do I have anything to help me out with du's up here? So even though you could have gone the whole denominator equal to u, and I think you could have eventually made that work, I think what I'm going to do instead is rewrite. And the reason why, when we go to do this one, e to the 2x, remember with a negative exponent, I can do 1 over. And complex fractions we can simplify by multiplying top and bottom by e to the 2x. So on top I get e to the 2x. On bottom I end up with e to the 4x plus 1. Oh, that was mean. You might not agree with me, but here's the sad thing. A is equal to 1. If I'm thinking of a's, what am I pondering? Inverse trig. What? Inverse trig? There's no square roots. Well, it can't be arcsine, can't be arcsecant. The only other one is arctangent. Arctangent says u squared plus a squared. Who's u squared? E to the 2x got squared to become e to the 4x. Oh my goodness, du is equal to 2 e to the 2x. I see him. So then we end up with dx is equal to 2 du over 2 e to the 2x. When I go to plug in, I'm going to end up with the integral of, do I have it? The e to the 2x's cancel. I can pull out a 1/2. I'm going to have 1 over u squared plus a squared du, which is going to equal, I pulled out my little 1/2. 1/2 times 1 over a, which is just 1, arctangent or tangent inverse of u over a. Sorry, I hear someone saying something. Do you guys need something? Oh. No, but I'm doing okay? No, go ahead, Ali. What do you see?
So u equals e to the 2x, right?
Yeah.
So you squared it. Wouldn't it be 4x squared?
But remember exponent rules. When we square, we raise a power to a power, we multiply, so 2x times 2 is 4x, or maybe a better way of seeing it, remember when you have like bases, you just add them. So I see what you're thinking, just it doesn't line up with the power rule, or sorry, with the exponent rules. There we go. Hey guys, if this was a long answer, could some of you guys have been totally sunk? To be honest. Yeah, it's a hard problem. But pause. Maybe it wouldn't be a long answer. What else could it be? If it's a multiple choice and you're stuck with where to go, what should you probably check out? The answer choices. Will one of the answer choices have an ln? Almost definitely, because if you made that your u, you might think 1 over u is going to an ln. I bet some of them would have ln's in them, but at least one should have a what in it? And if you see an arctan, you have to reorient your thinking. You have to just be like, could it be a u squared plus an a squared? Do you see what I mean? Sometimes you can work backwards from the multiple choice. And maybe your brain is thinking ln. You're like, it's not working. Then go see what else is in the answer choices. And maybe it would have been a power rule or an arctangent. Number 83. Oh, why am I going to say you see it? A squared minus u squared. So what would one of the answer choices have? An arc sign. A squared minus u squared. Why is this one going to work? Well, I can think ahead. Maybe some of you can't think ahead as far as doing math with calculus. But what I see is that little x is no problem because he's going to cancel out. I'm going to end up with a 1/2 times the integral of 1 over a squared minus u squared du, which is 1/2 times, arc sine is the 1, remember you were studying today, that does not have a 1 over a, right? Sweet. So I can do arc sine of u over a plus c, because it's not a definite integral, right? But why am I not going to go making a equal to 2 and u equal to x? What else is in this integral? An arctan. Some of you with a colored pen need to make yourself a note somewhere as far as studying for the test. Whenever you see an ln of in an integral or an arc trig in an integral, there is no way to integrate that you know, so you have to make that guy your u. Du would equal, this is where it gets a little messy, sorry, because the derivative rule for arctangent says 1 over 1 plus u squared times du, or times u prime. Sorry, I should have said u prime. 1 over 1 plus u squared times u prime. Some of you would have to do a quotient rule off to the side. It ends up being 2 over 4, which is 1/2. Some of you see that this could be rewritten as 1/2 x. Derivative is 1/2. Either way. The sad thing is you'd have to simplify this probably just a little bit to get 1 over 1 plus x squared all over 4 times 1/2. Maybe some of you see that we need to multiply this by 4 over 4 to make our lives easier. The 4 over 2 can become 2 over 1. The 4 multiplies in to be a 4. So we end up with 2 over 4 plus x squared dx, which ends up being quite nice. Sorry, guys. When it comes to solving. I'm going to put this off to the side just because I'm trying to get back to my integral one of these days. Oh, goodness, great. Oh. Don't know what just happened. Okay. So when I come to plug in, what am I going to see? I'm going to see u all over 4 plus x squared times 4 plus x squared all over 2 du. Looks like a w. Lo siento, it's a u. Pull out a 1/2. Integrate u. If any of you guys have ever caught yourselves answering an integral without anti-deriving, you got to be careful. I had to anti-derive u to be u squared over 2. I end up with 1/4. Who is u? This dude. Whew. All right. The one we didn't get to finish was this one just because it took a little bit longer than we expected. But remember, power rule. You have to anti-derive, then plug in your bounds, f of b minus f of a. It should work out with what you need in the back. Kiddos, we've done all the test review questions that you brought to my attention. We have a little bit more time. Are there any other test review ones that you want to see? AJ? I see a division. What am I going to ask you? Say it one more time, AJ. Is there a division rule? No. So what do we have to do? How do you guys divide? Could you write 2x to the negative 1? Ugh. Please don't do that. If you want to do x to the negative 1, pull out the 1/2, you can do that. But I don't know, guys. I'm really worried that you guys do it that way. I really think this is easier. It's up to you, but I'm just going to do it the way that I like best. 2x over 2x, I need to divide is 1 plus 1. Ooh. Isn't that like 1/2 times 1 over x? Why am I showing it like that? Yeah, it's ln. So I can just say x plus 1/2 ln of x. Nice thing is, I don't even need u sub for this one. Not really. Not really. As long as I remember I can divide. And remember, we always divide with pluses and minuses in the numerator. You can't do it vice versa. You can't divide this way and split up. You can only divide that way. So we're going to end up with 4 plus 1/2 ln of 4, f of b minus f of a, 1 minus 1/2 ln of 1. Some of you keep on forgetting this. What is ln of 1? Always, always. 0. Ln of 1 is always 0. 4 minus 1 is going to be 3. Could you guys have made it match if the final answer was 3 plus ln of 2? What'd they do? Yeah, 1/2 is an exponent. And an exponent, I mean, this one, you could have made a mistake and done some other math, but that's a square root. Dun, 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 dun. Any other test review questions? 79. Okay, I am going to go and just quickly peek at, guys, the practice test, because some of you guys have been working on the practice test. Ooh, AJ, this is a forever card. What's the integral of secant? Plus, got it. So if anything tripped you up, it might have just been the trig. Because there is no need for u sub. We can go straight to ln of secant theta instead of x or instead of u. Yeah, x instead of u. 0 to pi over 3. You just needed to know your rule. Trig. So you have ln of secant pi over 3 plus tangent of pi over 3 minus ln of secant of 0 plus tangent of 0. I'm just going to go pi over 3 real quick. Gives me a cosine of 1/2, a sine of root 3 over 2. Remember, ln of secant is 1 over cosine, so flipping 1/2 would be 2 plus, in my head, I think square root of 3 over 3, 1 square root of 3. He's the last one, square root of 3, or you can think sine over cosine. The over 2's cancel, root 3 over 1 is root 3, minus 1 over cosine of 0 is 1. Tangent of 0 is 0, so ln of 1 just ends up being 0. So my final answer. Okay, we're going to peek at the practice test just a little bit in case any of you have gotten to where you're like, I don't know why. Yeah, number 4. Is it okay if I go to the answer key? Okay. So for number 4, that way we can just look at the solution without reinventing the wheel. Number 4 is actually a lot like, here he is. Number 4 is a lot like one of the big idea problems at the end of your notes that I'm going to save when you guys leave today. If you do u sub with 1 over u, the reason you would do that is because there is an x up here. It's not just a 1 over. A 1 over, you should think arctangent. But since there's an x up there, I would, if I were you, try u sub. But du is equal to 2 times x plus 2. Ooh, there should be a dx. I apologize. A little typo on that. But if you went ahead and tried to plug in, maybe this jump is a little bit too intense. So let me take a picture right here. And then we'll expand it. There should be your dx. If you went to plug in, you would have your x plus 1 all over u times du over, what do you guys see? Take out the 2 and they match. Do you see it? Take out the 2 and they match. So then, that's the blank, right? Not a negative. I think that's the blank, sorry. 0 to 1. If I take out a 2, I'll have a 1/2 times the integral. My x plus 1's will reduce. I'll have a 1 over u du, which will take me back to 1/2 ln of x squared. There actually was no arctangent necessary because this guy matched perfectly with that guy if I just pulled out the constant. And then we need to plug in from bringing back our x bounds of 0 to 1. Now guys, tomorrow in the multiple choice, do you need to make sure that everything is perfect as far as your work on multiple choice? No, I'm not going to take off points if you're missing a dx in multiple choice. I'm not going to take off points if you're missing like the x bounds. But on long answer, what had you better do? Yeah, either write your x's or change to u bounds. At this point, it's a Priscilla, is that good? I did it again, Patricia. Why? I don't know. My brain's tired, and Priscilla's name is plastered all over my room. Go ahead. Oh, sorry. I didn't realize that there was going to be a problem. Divergent means there's a problem when you go to plug in. So when we go to plug in, Patricia, how do I do that? 1 plus 2 is 3, 3. The next one, when I plug in 0, I have all sorts of issues, except -3 in absolute value is okay. Actually, ln of 3 is the absolute value of a negative is good. The problem is ln of 0. Kid, how would we answer that? See it? So it'd be like negative infinite. This is not a constant. Since it's not a constant, we can just say divergent. It's not a constant. It's an infinite answer. And we haven't really seen infinite answers, but yeah. Good question, good question. Everything was perfect until we got an infinity, and then we're like, stop. Anything else on the practice test that someone's gotten stuck on or not understood? Do you have a problem, Michael? Oh, I thought you said a number. No, we're good? Okay. Pause. Some of you are looking at this practice test, and what are you thinking? So much. So wait, what's going to be at the end of your notes? For practice multiple choice. If nothing else, look at that. Make sure you have your forevers and study your review and your notes examples. But if you can, what's going to be good to look at? The practice test. Now, is that something you should stay up till 4 a.m. tonight, tomorrow morning? No. You need your brain to at least be somewhat engaged. Wait, tomorrow's a test. It's not a chapel day schedule, but can these take a while if you get stuck? Okay, 7:45 tomorrow. Be here, be ready. I'll pop over. It's 0 period. We'll kick kids out, and we'll let you guys get started at 10 till. Sound good? Okay. Kiddos, with that, I think we have 25 seconds. So please study your forevers. Anything to do with integration rules. No theorems I don't think are going to show up tomorrow. Some of you are like, yeah, we can use our calculators, right? No, because you could just throw it in and then, well, you'd be spending half the test just plugging in all the answers, seeing which decimals match. No, you're going to have to do it by hand, but that's okay. That's what we've been doing all chapter. Yeah? If you need anything during lunch, I'm not sure if I have a meeting or not, during period 7 is a good time after school. I'll only be here till about 3:45. So come quick if you need me. Cool? Okay. Otherwise, tonight, do you have someone on speed dial? Just kidding. They don't have to be in your favorites, but do you have someone that you can text to be like, hey, BC kid, hey, AB kid, hey, let's just do a FaceTime study sesh. Cool? Cool. All right, get out of here. I'll see you later. Yes, give someone a pat in the back, a high five, a hug, something on the way out, because you guys look so dead. I love you all. Hang in there.